Good morning, all. Please switch on your camera. After 5 minutes, you can switch off your camera.
Yeah, good morning, ma'am. Good morning, everyone.
Good morning, sir. Good
Good morning,
morning.
sir.
Good morning, Acha. Good morning. How are you all? Good?
All good, sir. Good morning.
Good morning. तो आज थोड़ा सा गैस कैरियर्स पढ़ने आपके क्राफ्ट सर पे ओके ना क्या कहते हैं लवप्रीत? लवप्रीत एकदम सीरियस है. I hope everything is okay with draft survey now.
Yes, sir.
चलो good. What about you, Gloria? Any doubts?
No, sir. All clear.
चलो good. So थोड़ा सा practice करते रहिए and remain in touch with these numericals so that you don't forget and आपकी जो इतनी hard work है, otherwise if you leave it for 10-15 days फिर थोड़ा सा out of touch हो जाता है. So at least once in a week एक आधा numerical पकड़ लिया और उसको keep doing it. Tankers की revision हम next week कर लेंगे so that you are up to date with the numericals. So that is a major part and the examiner also becomes positive कि ठीक है दो numerical ठीक है, so he starts giving you marks in a positive way. So इसको थोड़ा सा serious ले लीजिए. Mistakes are only that you are a little bit stressed up जल्दी में, and at least keep 10 minutes for revision. At least in दोनों questions को आपने कर लिया है, so you should time it in such a way that at least 5-10 minutes you complete your paper. I'm talking about the MMD, and you can give a just a glance through कि यार जो मैंने किया it's okay. That's all, not so difficult, but and I'm very sure slowly आपका confidence भी अब बढ़ता जाएगा. So once we come to revision, आपकी speed भी ठीक हो जाएगी. I think 20 minutes if you can do the numerical, nothing like it. And ये जो हमारी revision है, or even if you ask me the internal exam, it's a soft run, it's a practice that when I sit in the exam, so how you take it, it may differ, but I suggest you this internal exams are giving you a sort of feeling, or you know yourself where do you stand. कहने को मेरे को लगता है यार मेरे को सब कुछ आता है, मैंने प्रैक्टिस किया, बट व्हेन आई sit down there and start writing, and then you come to know your own weakness कि हाँ यार ये टॉपिक इसमें मैंने क्या क्या और पढ़ना है. So take it in that sense, not like कि पास फेल या मैंने सर्टिफिकेट लेना है या ये करना है. So this is the opportunity, and same way when we do practice, when we do revision, उसको भी इसी सेंस में लीजिए कि चलो न्यूमेरिकल है, let me do it without any assistance. कहीं अटकते हैं, then you can refer back to your books, notes, and you are through. चलो let's see what these gas carriers का भी एक क्वेश्चन रहता, but question wise it is not so difficult. आपके gas carrier basically if you see the hazards, type of gas carriers, cargo containment system, survival capability, that is a location of tanks, alarms and equipment, pumps, and reliquefaction which is done on these gas carriers, and finally the loading procedure which is slightly different from the tankers. Basically gas carrier has evolved out of tanker things only, similar to tankers, but इसमें थोड़ी सी और precautions हमारे पास अलग हो जाती हैं. So उसका procedure भी हम देखेंगे, how these what all things are carried out before we start loading gas carriers or liquefied gases. So if you see this development of this transportation of liquefied gases by sea, it started late 20s, and in the beginning the transportation of only propane, butane, and that also too in a fully pressurized tanks. And in around 1959, semi-pressurized ships, of course the research, the scientists who did, and then they found that certain gases, if you lower the temperature, they can be liquefied, and then the semi-pressurized ships came, they entered the market and the liquefied gas was transported under lower pressure, which was made possible by lowering the temperatures. By 63, fully refrigerated ships for LPG, LNG and certain chemical gases were in service carrying cargo at atmospheric pressure but very low temperatures. So liquefied gas is basically divided depending upon all these properties, and different groups of gases have led to different types of gas carriers. Because these gases are liquefied, certain gases are liquefied under high pressure, certain gases are liquefied under low temperatures. So that's why you have the few different types of gas carriers, so that some are fully pressurized, some are semi-pressurized, some are fully refrigerated. And as the development took place, the sea transport of these gases, it is internationally regulated with regard to safety through standards established by IMO. And these standards are set out in the gas carrier codes. So we all know that codes, today you have so many codes on everything almost. But here in this gas carrier code, they give you everything, right from the design, construction, safety measures. And I feel today these ships are much safer as compared to other ships. Now if you see, for economical reason, marine transportation of gas is carried in a liquefied state. If we have to carry this in a gaseous state, we needed very big ships. So you can see this as a liquid, the volume to weight ratio at atmospheric pressure is in the range of 650 times less than the gaseous state. So this is again the scientists who discovered, who did all this hard work, and today we can carry these gases in a liquefied state onto the ships, and how our life goes on. So this means we can carry 650 times more cargo in liquid state as compared to carriage of these gases in a gaseous state. Now for these gas carriers, temperature at which a gas condenses is a function of its pressure. And combination of pressure and cooling is therefore fundamental to gas carrier design. That's how we liquefy this gas. Some ships carry gases liquefied under pressure and others under refrigeration. And also if you notice, the relative densities of these gases are low, vary from 0.4 to methane and 0.97, that is VCM, vinyl chloride monomer, which is used in the manufacture of plastic. Cargo carrying capability is therefore more related to volume capacity of the ship than the deadweight capacity. Significant cargoes in terms of tonnage: LNG, LPG, butane, propane, ammonia, and other cargoes, of course, butyrene, butylene, ethylene, propylene, and vinyl chloride. So apart from this ethylene and methane, what we call LNG is more of a methane. Except these two gases, all these gases can exist as liquids at normal temperatures, whereas these gases are liquefied at very low temperature, -161 degrees centigrade. Now you can just imagine LNG ships carrying this liquefied gas at -161 degree centigrade temperature. So by thinking of it, it looks here what type of material, how they must have constructed the tanks, and how this gas is liquefied under low temperatures. Of course, technology is there today, and they may therefore be transported in pressurized cargo containment system at any temperature up to highest expected ambient temperature. So critical temperatures for ethylene, methane are below normal ambient temperatures, as I told you, -100, -160. And above the critical temperature, the gas cannot be transferred into a liquid at any pressure and must therefore be cooled. Now, all these conditions, that's why you see these gases are carried under various different carriage conditions, either fully pressurized or semi-pressurized or fully refrigerated. And similarly, if you see ethylene, methane or LNG, they are carried under fully refrigerated conditions because temperatures are -104 and -161. And similarly, materials exposed to these gas cargo should be resistant to any corrosive action of the gases. That for this reason, the copper alloys, brass have to be excluded from the cargo systems of ships intended for the carriage of ammonia. They have the corrosive effects, and details of materials of construction which should not be used. Chapter 17 IGC code. Everything is given there. Of course, people who build these things, they take care. They are intelligent, genius people who build the ships. Now, some basic definitions. Gas, again as per the gas carrier code, the liquid with a vapor pressure exceeding 2.8 bar absolute at a temperature of 100 degree Fahrenheit is normally what we term as a gas. Boiling point, as we all know, is the temperature in which the vapor pressure of a liquid becomes equal to atmospheric pressure, is the boiling point. Cargo area, we all know, as compared to tankers, what is cargo area, what is safe zones, what are hazardous zones. And similarly, cargo containment systems is basically your tanks. The arrangement for containment of cargo, including where fitted primary, secondary barriers, associated insulations, inter-barrier spaces. Basically, in a very layman's term, the gas carrier is like a thermos flask. The inner barrier, the outer barrier, in between there is a insulation so that there is no temperature change. So it is based on that design, and of course we see all these primary, secondary barriers and the insulation in between. Gas dangerous space, all the deck area where your tanks, pumps, compressors, reliquefaction plant, everything is situated is known as the gas dangerous zone. And gas safe zone, which is of course safer for other things, space on which not designated as a gas dangerous zone. Hold space and inter-barrier space. Again, if you see, these tanks are kept in the inside your hull, so naturally the hull is not forming a tank boundaries. So the space between your this tank and the hull is normally what we call the hold space. And inter-barrier space is between a primary and secondary barrier of a cargo containment system, whether or not completely or partially occupied by insulation or other materials. MAVS, abbreviation for maximum allowable relief wall setting on the ship's cargo tanks, and these settings are normally stated in your ship certificate of fitness. Primary barrier, like thermos I told you, primary and secondary barriers. If you look at these tanks, and this is the tank kept inside your hold space. Primary barrier, where you are loading the cargo, the inner layer, and again insulation is there, and in case the cargo leaks, so finally you have the hull acting as a secondary barrier, and cargo should not go out. That is the whole issue. So that's why you have this primary and secondary barrier. Tank dome, of course all the pipelines, everything is fitted on deck. There's nothing like under deck. Pumps are inside the tanks, and all these pipelines, everything basically passes through the what we call the tank dome pipelines. They are taken through the tank dome, which penetrates the deck. Now comes to the hazards. Common question भी हो सकता है कि yes, first of all, any cargoes we are aware, or anything if I am carrying, I should be aware of the hazards of that cargo. First of all, तो इसके साथ personal hazards, flammability, toxicity, asphyxia, low temperature, frostbite. When we are carrying these cargoes at such a low temperature, you can imagine even minus 50 degrees alpha low temperature, and when we are carrying at minus 161, so if a drop of that cold liquid falls onto our any part of the body, we can imagine what can happen. It is worse than the hot burn. Chemical burns, we all are aware. The flammability, very simple thing. Whenever we carry these liquefied gases or any even oil, first thing comes to mind is of course, this will be flammable. And the single most hazardous effect of these gases is the flammable nature of their vapors. The moment this liquefied gas gets converted into the vapor, And we also know it's not the liquid which burns, it is the gas. The liquid gets converted into the vapor, mixes with oxygen, and then the flammability takes place. And the vapors of all these liquefied gases are very easily ignited. Exception is ammonia, which requires little higher ignition energy. Emergency aspects: because of very rapid evaporation of the spilled liquefied gases, the spread of this flammable vapor, we can imagine if we just spread this liquid, it is immediately going to get converted to a vapors. Even the people who must have carried this naphtha on the product carriers, if you see this naphtha also, how quickly it vaporizes. So it is this aspect of this, liquefied gases, that it gets converted immediately into vapor, and the chances of ignition following a spill of liquefied gas is therefore much greater. So that's why you find all terminals, ships, wherever you are working, is totally a ignition free zone. And I think by way of working on tankers or these ships, now it is basically, it becomes our nature that we do not allow any spark, anything, any flame coming close to these areas. Radiation from liquefied gas fires, because of rapidity of vapor production, can be intense. So we cannot go and fight the fire in normal condition as we do with the other solids fire. So again, the firefighting, proper protective clothing. In case we come across such a situation, God forbid it should not happen, but before attempting, we should have this much in our mind, that it is a vapors and they spread very fast. Toxicity, I think we all know, but we have studied even in chemicals, that same effect of toxicity on the human health. It can take place, it can cause a permanent health hazard, irritation, tissue damage, impairment, and they can result from skin or open wound contact, inhalation or ingestion. So toxicity though we have studied in detail. Contact with cargo, liquid or vapor should be avoided. Protective clothing, most important, and toxic gas detection equipment. Asphyxia, very common with these gases. The human body requires 21% oxygen. So this asphyxia is just a suffocation. So these gases, what they do? They basically replace your oxygen. And if there is a deficiency of oxygen, you know what can happen to us. So susceptibility of persons to reduced oxygen levels vary, but at levels below about 19%, now we know, we all have been very thorough, we need 21% oxygen. But little bit level, okay, 20, 19, still we can survive, but there is you can start feeling the effect of this low oxygen, especially when you go to very high altitude. There also some people face a breathing problem because of less percentage of oxygen. So same thing is here. So in case the oxygen level goes below 16%, immediately the unconsciousness takes place. So these gases have this effect when you are carrying in any space. So oxygen is replaced, there is no oxygen. So asphyxiant effect is very much present with these gases. So such a problem is limited to enclosed spaces. Oxygen deficiency in enclosed space can occur when large quantities of cargo vapor are present, large quantities of inert gas, nitrogen present, and where rusting of internal tank surfaces has taken place. So tanks are empty, it may be in an inert condition, or when they are full, it may be full of these gas vapors. So it is essential to prohibit entry to any space until the oxygen content is 21%. And different levels and widely dispersed within the space. Now, of course, this is asphyxiation and medical treatment. Of course, I think you have studied enough in the first aid or MFA Medicare courses, that what to do in case a person is suffering from the loss of oxygen. So first thing becomes remove the casualty to a safer area where he can get more and more fresh air. Now another effect is anesthesia. Anesthetic effect is also there. What is anesthesia? Is simply loss of consciousness, the effect on the nervous system. As a medical officer on the ships, we all know that what is anesthesia. If we have to do some repair on the human body, so we definitely give anesthesia, local anesthesia. You want to do a stitching also, stitch lagane, then also the doctors give this. So these gases have got the same effect of anesthesia, loss of consciousness due to effect upon the nervous system. The unconscious person may react, but can only be roused with great difficulty. Again, precautions can be avoided by use of cargo vapor detection equipment and breathing apparatus. Frostbite, extreme coldness of some of these liquefied gases, significant hazard, frostbite. And it is quite dangerous. That it is, it's not that it gives you only burn, it even sets up, it starts, your cell starts dying, and what we have, the gangrene, and then that particular part maybe it needs to be amputated. So frostbite is a very, very dangerous thing, especially, so better we take this hazard very seriously. And for fully pressurized gases, while containment system will normally be at or near ambient temperature, liquid leaks will quickly flash into fully refrigerated temperature. Such areas should never be approached without proper clothing. Symptoms of frostbite: extreme pain, confusion, agitation, and possibly fainting. And if the affected area is large, severe shock, and it can cause even death. Initial symptoms, if you see frostbite common, a lot of engineers suffer when they're handling this refrigeration system on the ship, a very cold pipeline if they touch. So they see these cold burns. So it is similarly, the skin initially becomes red, then turns white. The affected area is usually painless, hard to touch, and if left untreated, the tissue will die and the gangrene may occur. And of course, treatment is to warm the area, warm the particular affected portion. And blister should never be cut nor clothing removed. Dress the area with sterile gauge. And of course, immediate medical attention. But the worst thing is, if it is left untreated, नहीं ठीक हो जाएगा या ठीक हो गया, the tissue dying or the cells dying, that gangrene is a very, very dangerous disease. It needs amputation to save the body. Chemical burns, we are also exposed: ammonia, chlorine, ethylene oxide, and propylene oxide. Their symptoms are similar to burns by fire, except the product may be absorbed through the skin. Ammonia is a gas. I think I went on one of the ships, and the ship is full of that ammonia smell. तो केमिस्ट्री लैब याद आती है कि अमोनिया की स्मेल है, यस, आपके कोल्ड को ठीक कर देती है. If you are suffering from cold, you inhale a little bit ammonia, cold becomes all right, but of course it has got a very typical pungent smell. Ships carrying ammonia, all the accommodation, you will see this smell is all around. And chemical burning, of course, it is damaging to eyes. It can enter your body through the skin also. Again, burning pain, redness of the skin, irritating rash, blistering of skin, and toxic poisoning, all associated with your ammonia. Treatment, again, eyes and skin, we should attend first. Wash copious amount of water. Wash the skin thoroughly. And on gas carriers authorized to transport these products, that's why you have these deck showers, eye baths are provided for water dowsing. Their location should be clearly indicated. In case of emergency, these things become important as a chief officer, that yes, systems are working properly. Of course, we don't expect anything happening, but God forbid something happens. The first thing is the amount of water should be available, deck showers, or the amount where we can wash this affected area. ये तो थे इसके personal hazards. Now if you see the other hazards as compared to what we have studied in the chemical tankers, here also we have reactivity. Now liquefied gas cargo may react in number of ways. It can react with water to form hydrates, which is again not a good thing. So you can imagine in a tank when we are carrying these gases at such a low temperature, if there are a few drops of water are there, they can freeze, and this is normally known as the formation of hydrates. And these crystals formation can be definitely damaging to the pumps, bearings, anything. So first danger with these gases, the activities, they can react with water, they can react with air, they can react with another cargo or other materials, similar to your chemical tankers. Reaction with water, some hydrocarbon cargoes will combine with water under certain conditions to produce a substance like a hydrate resembling like a crushed ice or slush. And water for hydrate formation can come from purge vapors with an incorrect dew point, water in the cargo system, or water dissolved in the cargo. And care should be taken to ensure that dew point of any purge vapor or inert gas used is suitable for the cargo concerned. And the water is excluded for this from the cargo system. Otherwise, hydrates can cause pumps to seize, equipment to malfunction. So these are the, of course, we'll see how these things are taken care when we do this procedures before this loading takes place, what all things are done to get rid of this any water present in the tanks. Certain cargoes like LPGs may contain traces of water when loaded. It may be permissible in such cases to prevent hydrate formation by adding small quantities of antifreeze. Of course, the terminal, anything they do, normally we don't add, we don't have to do anything with the cargo. It is of course the shipper or the terminal they have to do. It is permitted, it should be introduced at places where expansion occurs a resultant lowering. No, antifreeze additives are often flammable, toxic, care should be taken for their. Of course, on the ship we don't mix anything with this. Self-reaction, some cargoes may react with themselves. अब ये भी है. The most common form again, polymerization. ये भी liquid cargoes ही हैं. If you consider, these are gases but they have been liquefied, now it's a liquid, they can have a self-reaction. Self-reaction is a vigorous polymerization which may be initiated by presence of small quantities of other cargoes or by certain metals. And polymerization we have studied, it produces heat which can accelerate the reaction and then the temperature and pressure go up. Now, if these cargoes are such, again in case solution, how to carry them is again under inert gas blanket or to be inhibited. Inhibitor is added so that this reaction doesn't start. And if it is done, आपके पास इसका data भी होना चाहिए कि yes, what is the quantity and what is the type of inhibitor added and उसकी effectiveness कब तक रहेगी. And the action to be taken should the voice exceed the effective lifetime of inhibitor. Any temperature limitations. And of course, there is no need to add anything during the cargo, during the voyage. If it should become necessary, should be made according to the shipper's instructions. So we don't touch this cargo, we don't want to spoil, we don't have the means also on the ship to do it. And similarly, of course, this is too much detail that we have studied in the chemical cargo. Same thing, reaction with air. Now this is also very much possible with these liquefied gases. And they can react with air to form unstable oxygen compounds. And इसके लिए remedification is, what is the rectification rather, that how we carry under nitrogen. Oxygen निकालनी तो we are very much thorough with it, inert gas. So normally we don't use inert, we use pure nitrogen and oxygen के साथ reaction का chances are absolutely reduced. Reaction with other cargoes, of course, certain cargoes can react dangerously with one another. They should be prevented by mixing, using separate piping, vent system, even their vapors, everything, every tank has a individual venting system so that no two cargoes vapors mix and create any disaster on the ship. And data sheets list material which should not be allowed to come in contact with the cargo. MSDS sheets, they give you clearly materials used in cargo systems must be compatible with the cargoes to be carried, and care should be taken no incompatible material like your maintenance from gaskets, pump seals, anything, whatever is made, it is made in such a way that that is not going to react with these liquefied gases. Reaction can occur between cargo and purge vapors of poor quality. Inert gas with high CO2 content can cause carbonate formation with ammonia. Reaction can also occur between compressor lubricating oils and some cargoes. So इसके लिए inert gas को भी probably they replace with nitrogen, so no carbonate formation takes place. Corrosivity, some cargoes and inhibitors may be corrosive, so care should be taken to ensure unsuitable materials not introduced. Corrosive liquids, we have seen affect both human tissue as well as the equipment. So equipment, of course, building time they take care that what all cargoes the ship is carrying, authorized to carry, approved to carry, and touching these corrosive liquids, again proper protective clothing is the solution. Low temperature effects, that is also there. The liquefied gas cargoes are often shipped at very low temperatures, important temperatures, sensing equipment well maintained. A lot of sensors, lot of gauges are there on these ships, and they have to work to the maximum accuracy. A low temperature effect is a brittle fracture. I can imagine if -100 or -150 degree liquid falls on deck, it will immediately cool the deck or the steel to such a low temperature that the metal becomes brittle. It can, what is brittleness? It just breaks. Like if you compare mild steel with stainless steel, mild steel को you can bend, it doesn't break, whereas stainless steel you see थोड़ा सा bend किया straightway breaks. So most metals and alloys become stronger but less ductile at low temperatures. That is, the tensile and yield strengths increase, but the materials become brittle and the impact resistance decreases. Slight impact, it will break into two, because the reduction in temperature changes the material's crystal structure. And that's why your steel decks or anything, when this so-called liquid falls on the deck, it can create that brittle structure, brittle fracture. So normal shipbuilding steels rapidly lose their ductility and impact strength below 0 degree. So you can imagine the tanks, the material used for tanks, construction of tanks to carry these liquefied gases at such low temperatures. One of the material is Invar. So that Invar is basically a nickel and carbon steel. It's a special steel which can stand these low temperatures without getting any effect. So that's why a lot of other metals which are chosen for during the construction of these tanks which are going to carry these liquefied gases at such a low temperature. So for this reason, care should be taken to prevent cold cargo from coming into contact with such steels, as the resultant rapid cooling would make the metal brittle and cause stress due to contraction, and in this condition the metal will be liable to crack. So this is a precaution we have to take, that these cold cargoes do not spill on deck, and if they spill, there are chances that metal become brittle and can crack. Spillage, avoid hazard of personal and danger of brittle structure. If spillage does occur, source should be first isolated and spilt liquid then dispersed. Cool down Of course, systems are designed to withstand a certain service temperature. If this is below ambient temperature, the system has to be cooled down to the temperature of cargo before transfer. Of course, we will see how these tanks are cooled down. From ambient temperature, if I am going to load cargo at minus even 100 degree, so we just cannot put this cargo into the tanks. Thermal stresses will take place, brittle fracture can take place. So these tanks are normally cooled at about say 10 degree per hour. You cannot immediately cool also. Sudden cooling also causes a lot of thermal stresses. So that also we'll see during the what are the procedures of cargo operations, that how this cooling of tanks is done. Ice formation, of course, what we have seen, low cargo temperatures can freeze water. What we have seen, hydrate formation and all that, उसको avoid करने के लिए भी antifreeze or anything can be added. Now the biggest thing, the rollover, which is associated with these cargoes, and इसमें question भी आ जाता है. Lot of time in the returns and even in orals also, the examiner probably will ask you what is rollover. Now, rollover is a very simple thing to understand, that you are carrying these liquefied gases in a tank. Now slight temperature change, this vaporization starts, what we call the boil off. This liquid starts vaporizing. What is the term used is boil off. Now as the top surface, the top layer of the liquid vaporizes, the density of that top layer changes. So basically it becomes more denser and denser, and sometimes these cargoes have a lot of impurities, and these impurities, they start vaporizing very rapidly, which is making the top layer a little denser as compared to the layers beneath. So this layer formation, what we call the stratification. Now the stratification develops, the liquid layer adjacent to a liquid surface becomes denser than the layers beneath due to the boil off of a lighter fraction from the cargo. And especially even if you see this LNG methane, it has got a lot of impurities, and these impurities immediately boil off, immediately vaporize, and the top and the liquid surface, the top surface of the liquid becomes more denser. And now these two different densities or two different liquids adjacent to each other are lying. There is a tendency that this spontaneous rapid mixing of these two layers is normally what we call the rollover. So this is, of course, when this layer formation stratification takes place, this is a very unstable situation and relieves itself with a sudden mixing of these two different density liquids. So this is what the rollover is called, and when this takes place, the temperature, pressure can suddenly go up very much, and these tanks are not designed to stand very high pressures. They can stand very low temperatures but not high pressures. So there's a danger of the rupture of the tank. So this is what basically the rollover is. The liquid hydrocarbons are most prone to rollover, especially cryogenic liquids, means refrigerated liquids, which are at very low temperatures. LNG most likely by virtue of its impurities it contains, and the extreme conditions of temperature under which it is stored, close to the saturation temperatures at storage pressures. And if the cargo is stored for any length of time and the boil off is removed, evaporation can cause a slight increase in density and a reduction of temperature near the surface. So the liquid at top of the tank is therefore marginally heavier than the liquid in the lower levels. And this layer formation, or what we call the stratification, has developed and rollover can occur. अब इसका solution क्या? Now this inversion will be accompanied by a violent evolution of large quantities of vapor and a very real risk of tank overpressure. Rollover has been experienced ashore also, but may happen on a ship that has been anchored for some time. So that means this rollover can take place when your cargo is almost stationary, not moving. It can happen, yes, like the ship is stationary at anchor, then there is a possibility. So उसकी prevention के लिए such circumstances are foreseen. The tank content should be circulated daily by cargo pumps to prevent this rollover occurring. So cargo recirculate होता है, then there's no chances of this layer formation. So this is totally your basically rollover, what rollover is and how it can be avoided. So can also occur if a similar or compatible cargoes of different densities are put in the same tank. तब भी हो सकता है. चलो ये तो थे हमारे hazards, personal and reactivity hazards and rollover. अब आपका आ गया gas carrier types. What are the various gas carriers? ये भी क्वेश्चन आता है रिटर्न में. Simple. Even you have not been on gas carrier, doesn't make a difference. We can definitely answer this question that gas carriers can be grouped into 5 different categories according to the cargo carried and the carriage conditions. जैसे हमने देखा, these gases are liquefied under different conditions, either high pressure or low temperatures. So accordingly, ship's design also is as per these conditions. First is fully pressurized, semi-pressurized, ethylene ships, fully refrigerated LPG ships and LNG ships. Now first 3 types listed are most suitable for shipment of smaller size cargoes of LPG and chemical gases, and normally accomplished on short sea routes, and fully refrigerated ships extensively used for carriage of large size cargoes of LPG ammonia on deep sea routes. Now what is fully pressurized ships? From the word only we see cargo is at high pressure. Now if you have to carry cargo at high pressure, the tank should be thicker steel, and if you use thicker steel, naturally the tanks will be heavy. So these fully pressurized ships, simplest of gas carriers, carry cargoes at ambient temperature, but only high pressure. Temperature is same like your LPG cylinder at home. The cargo is at normal temperature, but it is under high pressure. So they are fitted with type C tanks, pressure vessels, what we call, fabricated in carbon steel, having typical design pressure to stand. These tanks can stand 18 bar gauge. So 18 bars pressure means the thickness, the wall thickness of this material must be sufficient. And ships with higher design pressure in service, few ships can accept up to 20 bar gauge. No thermal insulation, no liquefaction plant is necessary for these type of ships. Cargo can be discharged using either pumps or compressors, and because of their design pressure, the cargo tanks are extremely heavy. Naturally, they are made of thicker steel, so they will be heavy. So as a result, fully pressurized ships tend to be small, having cargo capacity of 4,000 to 6,000 meter cube, and primarily used to carry LPG or ammonia. Ballast, of course, carried in double bottoms, and these ships are fitted with type C containment system, no secondary barrier required. Second type is semi-pressurized ships. Now semi-pressurized means the ships are similar to fully pressurized type C tanks, and in this case pressurized vessel designed typically for lesser pressure. वहाँ पे 20 bar था, यहाँ पे 5 to 7 bar compared to fully pressurized ships. So reduction in tank thickness due to the reduced pressure, cost reduction भी होगी, plus refrigeration plant and tank insulation भी चाहिए, because they are semi-pressurized and semi-refrigerated. So this type of gas carrier has an optimum means of transporting a wide variety of gases such as LPG, vinyl chloride, propylene and butadiene, most frequently found in busy coastal trades in Med Sea, Northern Europe. Is the most popular amongst operators, these semi-pressurized ships. Tanks in KV type C we will see when we study type C, type A, type B, type C tanks. Therefore do not require secondary barrier. Cargo capacities 3,000 to 20,000, and tanks usually made from low temperature steels, because now we are lowering the temperature or we are loading the cargo with low temperatures. So tanks की जो construction है, of course they should be able to stand low pressures and also 5 to 7 bar का pressure also, low temperature also and little high pressure also. So normally the material used, they can easily stand -48 and which is the temperature suitable for most of the LPG and chemical gases. Alternately, they can be made for special alloyed or aluminium to allow for carriage of ethylene at -104. Ethylene ships are of course specially designed in such a way that this cargo is carried at -100, -104 and designed to load from both pressurized and refrigerated storage facilities. तो ये तो आपका pressurized and semi-pressurized. And third is your ethylene ships. They are often built for specific trade, carrying LPGs or chemical gases. इनकी capacity is normal 1000 to 12,000 meter cube, and ethylene as it is carried in fully refrigerated condition. Normally type C tank of pressure vessel tanks are used. No secondary barrier, thermal insulation, high capacity reliquefaction are fitted for these type of ships. So reliquefaction plant is also important in these gas carriers. Examination point से भी है, उसको भी देखेंगे reliquefaction plant क्या होता है. Basically it is to जो आपके vapors हैं, sudden temperature changes, cargo vaporizes, and these vapors जो हैं उसको control करने के लिए we convert these vapors back into the liquid, that is a reliquefaction plant. Up to ethylene के लिए possible है, but इससे low temperatures के लिए of course the plant starts becoming bigger and bigger. So complete double hull is required for cargoes below -5, whether type tank A, B, C, anything is carried. Fully refrigerated ships carry their cargoes at approximately atmospheric pressure and designed to transport large quantities of LPG ammonia. So यहाँ पे 4 different cargo containment systems have been used for these ships. Why? Because they are fully refrigerated, special metal, special construction. So they are independent tanks with single hull or double bottom and hopper tanks, independent tanks with double bottom, integral tanks and semi-membrane tanks. So fully refrigerated ships के लिए आपके पास independent tanks with single hull and independent tanks with double hull, integral tanks which are incorporating a double hull and semi-membrane. So for this type of ship, tank itself is a type A prismatic freestanding unit capable of maximum working pressure, very low 0.7 bar. The tanks are constructed of low temperature steels to permit carriage of cargo up to -48, and fully refrigerated ships range in size from they are bigger 20 to 100,000 meter cube, and relatively fully refrigerated ships between 55 to 70,000 meter cube. Ethylene के बाद आपके LNG, these are also fully refrigerated, but here the temperature is quite low. Anybody worked on these LNG ships? LNG carriers? हाँ, क्या कहते हैं? Is there anybody who has worked on LNG ships? नहीं है, nobody? चलो. LNG carriers, specialized types of gas carriers built to transport large volumes of LNG at -162 degrees. So these ships are practically bigger in size, 125 to 335,000 meter cube capacity, normally dedicated for a specific project, and they remain throughout their life. They carry only between 2 or 3 ports, and they are designed in that way that particular plant or particular project they have to keep feeding. Containment system on these ships basically of 4 types. Containment system means your tanks: gas transport membrane, Techni-gas membrane, Cuvier-Bosch spherical, and IHI SPB tanks, prismatic tanks. So these are the 4 type of tanks. Of course the details are there in the IGC code, that for this LNG what are these. different type of tanks are there. So LNG ships have double bottom or double hulls throughout their cargo length, which provide adequate space for ballast. And ships fitted with membrane systems have a full secondary barrier. Membrane system, of course, a very thin material which is used, and they have a primary and secondary barrier, and type B design have a drip tray pan type protection. Now, characteristic common to all LNG ships is that they burn their cargo boil off. जो उनकी vaporization है, जो vapor हो जाए, so the liquid which gets converted to vapors, they cannot convert back to the liquid because you need a very bigger reliquefaction plant, which is not possible on the ship. So that's why they burn this vapors of LNG. What we call the boil of LNG is taken as a fuel. Hold spaces around cargo tanks are continuously inerted, except in case of spherical type B containment, where hold spaces may be filled with dry air provided there is an adequate means of inerting. Most of the LNG carriers, of course, they have steam turbine because they want to burn this boil off of the cargo. So we are going back to these LNG ships are again steam turbine boiler, just heat up steam and then steam turbine. Cargo containment system means tanks, the type of tanks, which all type of tanks are there. So इसके ऊपर भी कई बार क्वेश्चन आ सकता है कि yes, what are the various types of tanks you have and what this system is for containing cargo, including where you have primary barrier, secondary, thermal insulation, intervening spaces and adjacent structure for support of these elements. So cargo containment का कि yes, the cargo should not basically leak out in case of whether any structural damage or any leakage. The cargo should not spill out because it will definitely harmful to the environment. So that is the whole idea, how to contain. Like chemical tankers also we are doing the same thing, where the tanks are kept away from the hull, and here the leakage also, if the leakage takes place, that's why this lot of primary and secondary barriers are fitted. So इसमें सबसे पहले आ जाता है आपका independent tanks. These are the simplest ones, completely self-supporting, do not form part of ship's hull structure. It is simply that the tank is kept into your cargo hold. So moreover, they do not contribute to the hull strength because it is something which is kept into the hold. So it will not definitely form any structural member of the ship. So as defined, that depending mainly on the design pressure, there are three different types of independent tanks, type A, B and C. So we will see this. चलो थोड़ा ब्रेक ले लें, फिर देखते हैं टाइप ए, बी एंड सी किस किस टाइप के टैंक्स होते हैं. ठीक है, टेक अ ब्रेक 10 minutes, 15 minutes.
Okay, sir. Thank you.
Yeah, so 10-15 we'll meet. Yeah, okay, dear, all of you are there?
Yes, sir.
चलो ये तो बच्चे आप पढ़ लेना. This is the various type of tanks. So briefly I have described all here. इसके बाद आपका next आ जाता है the survival capability or what we call the tank location. So these are the different tanks, integral tanks और क्या क्या होते हैं. So survival capability and tank location. What exactly this is the ship subject to code shall survive the hydrostatic effects of flooding when your hull damage caused by some external force takes place. So इसके लिए same like if ships run aground or stranding or anything, the cargo should not spill out. So in addition to safeguard the ship and environment, the cargo tank shall be protected from penetration in case of minor damage to ship resulting from example from contact with jetty or tug, and also given a measure of protection from damage in case of collision grounding by locating them at a specified minimum distances inboard from the ship's shell plating. So chemical में भी यही था. यहाँ पे भी again your survival capability is the ships subject to code are designed to one of the following standards, what we call 1G, 2G, 2GP and 3G. So these ships are again intended to transport products indicated in chapter 19 that require maximum preventive measures to preclude their escape. So again their location, if you see in the IGC code they are given how far they should be located from the hull and all the distances, details are given, of course, which is taken care during the building time. But इसकी knowledge भी कि survival capability is then only possible that if the ship gets damaged, cargo tanks do not get damaged. So that is how their design is made. Type 2G, again intended to transport products indicated in chapter 19 that requires significant preventive measures. यहाँ पे maximum preventive and significant to preclude their escape. And 2PG is a gas carrier of 150 meter in length or less intended to transport the products, and that requires significant preventive measures to preclude their escape. And where products are carried in type C independent tanks or MAVs of at least 0.7 megapascal gauge and a cargo containment system design temperatures of -55 or above. And ship of this description that is over 150 in length to be considered as type 2G ship. And similarly type 3G ship is a gas carrier intended to carry products which are indicated which require moderate preventive, so means less preventive measures. So उनके distances जो हैं आपके accordingly less हो जाएंगे. So therefore 1G ship is a gas carrier intended for transportation of products considered to present greatest overall hazard, and type 2G, 2PG and type 3G for products progressively lesser hazards. So this is to understand that survival capability, what do they mean, and accordingly type 1G ship shall survive the most severe standard of damage and its cargo tank shall be located at maximum prescribed distance inboard from the shell. And ship type required for individual products is indicated in column C of the chapter 19. And ship intended to carry more than one products listed in chapter 19, उसका standard again for the worst one or the most stringent type of ship जो type का cargo carry करना, if it is extensive, I mean precautions are required, then you will have 1G type. In case the ship is carrying 1G, 2G, so she should be built according to the 1G specifications. अभी आपके high alarms, of course these ships have this lot of gauges, alarm sensors fitted in the even for the automatic shutdown. So with the exception of type C tanks having capacity of 200 cubic meters, every cargo tank must be fitted with an independent high level sensor giving audible and visual alarm. So this is again for the safety that high level alarm or other independent sensor is required to automatically stop the flow of cargo. but यहाँ पे again है कि there should not be any pressure surge. So again the timing of that valve should be so adjusted that there is no overflow, at the same time there is no damage to the pipeline due to the pressure surge. Gas carrier codes, if you see this is also ships have been transporting from so many years, and as the technology keeps changing, so purpose of this code is to provide standards for safe transport, and this is done by the code prescribing design and construction standards. So अगर आप देखिए, the basic philosophy is assigning one of the ship types as per the hazards of the products carried. So hazards in gas cargo arise due to the products being transported under refrigerated or pressure conditions. So इसी के हिसाब से आपके gas carrier code जो हैं, which of course they keep amending as per the new innovations taking place. Severe collision strandings could lead to cargo tank damage and uncontrolled release of product. So such release could result in evaporation and dispersion of the product, and in some cases could cause brittle fracture of the hull. So requirements in these codes are intended to minimize these risks depending on the present technology. उसका layout of this code is in line with the आपका chemical code की तरह ही, IBC की तरह. Overall layout of gas carrier similar to that of conventional oil tanker from which it is involved, and cargo containment system and its incorporation is however very different due to need to carry these cargoes under high pressure or refrigerated conditions. ये सिर्फ अलग हो जाता है. अब ये जो कोड है, again gas carriers built before or built after June 86, IGC code, which applies to new gas carriers built after 30th June of 86. तो इसके लिए आपके पास this code for construction and equipment of ships carrying liquefied gases, and we, in short, we call it IGC code, mandatory for all ships, and as a proof that ship complies with the code, कौन से कोड से अप्लाई कर रहा है, GC code या IGC code, so you have the certificate of fitness. Now if you have international certificate of fitness for carriage of these liquefied gases should be on board, that completely indicates that you are complying with the IGC code. And the ships built before used to have GC code, वहाँ पे आपके पास आ जाएगा regulations covering these carriers built after 76 but before 86. So same thing, construction equipment, and इनके लिए आपके पास जो certificate आएगा, that will be again the, there it was word international, here आपका international word जो है वो निकल जाएगा. That means this is complying with the old code. And ships built before 77 contained in the code, or existing, what we call the existing ships, इनका content is also similar to GC codes. So certificate of fitness जो है, when you look at it, उससे आपको पता लग जाएगा your ship is complying with GC code or IGC code. So IGC code, of course, things are a little stringent because you have to comply with more things. So GC code, the old ships, they either try to scrap and go for the new ship instead of fitting the new things into this. So certificate remains valid dependent on the results of survey period of 5 years, assuming from the ship has not changed flag, and where the ship is designed in accordance with the new IGC code. Of course, we have the certificate called International Certificate of Fitness for carriage of these gases. So such certificates signify minimum standard of constructional safety. So international होगा तो I know we are complying with all the rule regulations of IGC. अब इन ships में आपके pumps, we have two types of pump. What we have, deep well pumps and one is submersible. So deep well pumps, most common type, and is operated electrically or hydraulically by a motor which is flange mounted outside the tank. Framo pumps drive shaft guided in carbon bearings inside the discharge tube, and these bearings are lubricated and cooled by your cargo flow of the discharge tube. तो यहाँ पे अगर आपने देखा केमिकल में we have only one impeller, here you have the 3 impellers or 3 stage impellers which basically push this liquefied gases out. So This deep well pump's impeller assembly is mounted at the bottom of the cargo tank and will frequently comprise 2 or 3 impeller stages together with the first stage inducer, and this later is an axial flow impeller used to minimize your NPSH, that is net positive suction head requirements for the pump. Shaft sealing arrangement again कई बार इसके ऊपर भी आ जाता है. Write short notes on the deep well pumps used in the cargo handling. And second time आपका submerged pumps. This type of pump is used for LNG carriers and many large fully refrigerated ships. So इसकी assembly is different. A pump is situated inside and well protected. Power supply to the pump motor through copper stainless steel sheeted cables which pass through a gas tight seal in the tank dome and terminate in a flame proof junction box. Submerged pumps, their motors cooled and lubricated by cargo figure, and this is how these your submerged type of pumps look like. Everything is inside. अब आ गया reliquefaction plant जिसके ऊपर क्वेश्चन कॉमन है. Now ये reliquefaction plant है क्या and how this controls the boil off of the cargoes. Now this is again with the exception of fully pressurized gas carriers, means must be provided to control cargo vapor pressure in cargo tanks during cargo loading and on passage. In case of LPG chemical gas carriers, a reliquefaction plant is fitted for this purpose. And this equipment is designed to perform basically the following functions. To cool down the cargo tanks and associated pipelines before loading. And second, to reliquefy the cargo vapor generated by flash evaporation during the passage, liquid displacement and boil off during loading, and to maintain cargo temperatures and pressure within prescribed limits while at sea by reliquefying the vapors which are generated inside your tanks. अब इसके types भी अलग-अलग हैं. There are two main types. One is what we call direct cycle, one is indirect cycle. So direct cycle are the most ones which are used, where evaporated or the displaced cargo vapor is compressed, condensed, and then returned back to the tank as a liquid. Most commonly used system. And indirect, where external refrigeration system is employed to condense the cargo vapor without being compressed. So ये थोड़ा कम है. So direct system में भी अगर आप देखिए, there are 3 types in the direct cycle system. One is single stage direct cycle. ये क्वेश्चन भी आपको आता है, what is reliquefaction of liquefied gas carriers and how it is done on the gas carriers, or what are the various types, describe any one of them. So be careful when he writes various types. You can describe the various types but describe only one of them. Sometimes I have seen the people describe all 3 of them. This is again a waste of time. In case if he is asking only one, then we describe only one. So इसमें 3 types हैं. One is single stage, very simple, cargo tank, and there the vapors are there. Now these vapors are basically sucked by the compressor. Now they go to the compressor. Here the vapors are compressed, same like normal refrigeration system. But again temperature, pressure goes up, and then it is cooled in the seawater cooled condenser, and then they are passed through expansion valve. There basically they get converted into the liquid and back into the tank, either through the spray rail or through the bottom pipeline, whichever system is fitted. So this cargo vapors through compressor, condenser, and back as a liquid into the tank. So this way your pressure doesn't exceed in the tank. So these vapors do not generate extra pressure. Tanks are not built for standing high pressure. So single stage direct cycle is where suction pressures are relatively high, as in carriage of semi-refrigerated products. Then this cycle is suitable. Boil off vapors from the cargo tanks are drawn off by the compressor and compressed, and compression process increases the pressure and temperature of the vapor, allowing it to be condensed against seawater cooled condensing. And this condensed liquid is then flashed back to the tank via float controlled expansion valve. And the returned liquid or the vapor mixture, it may be slightly, not completely converted to liquid, but this mixture to the cargo tank either distributed by a spray rail at the top of the cargo tank or taken to the bottom of the tank to discourage more revaporization, depending on the whether tank is empty or full respectively, because sometimes we do spray it to vaporize to cool the tank, but here it is basically to reduce the vapor pressure to convert these vapors back into the liquid. Two-stage direct cycle. If you see this is also similar but slightly different, that where you find this the two-stage cycle with interstage cooling is used, where suction pressures are low and as a result compression ratios are high. So यहाँ पे भी same thing, vapors drawn up to the compressor, then they go to the intercooler where it is again cooled through part of this cargo, only part of this liquid it is cooling here and part of the liquid going back. So from here again the vapors are taken to stage 2 compressor, where it is again cooled through a seawater compressor, and then as a liquid, part of this liquid goes to cool the intercooler and rest of the liquid goes back to the tank. So this is two-stage direct reliquefaction cycle, and it is again the two-stage compression with cooling between the stages is therefore sometimes necessary to limit compressor discharge pressures, which increase significantly with the increasing compression ratios. Vapor from first stage discharge is taken to an intercooler where its superheat is removed, and then it goes to the second stage and cooling medium is cargo liquid in the intercooler, flashed down to intercooler pressure from the seawater cooled condenser, and remaining part of the cycle are similar to the single stage. Cascade type, another direct cycle system where another refrigerant is used to condense the cargo vapors. Instead of seawater cooled, here another refrigerant is used, and the single stage compression of cargo vapor is identical to the single stage direct cycle. So here instead of cooling this condenser by the seawater, it is cooled by another refrigeration system, another compressor which is seawater cooled, and this liquid or this refrigerant is basically cooling this condenser so that even the superheat generated, it is well taken care in this condenser instead of just cooling by the seawater. So this is called the cascade type reliquefaction cycle. These three direct reliquefaction cycle systems are the most common. One of them is fitted. Of course, it is very basic, very simple. It's quite a complicated machinery. Engineers take care of it. It looks so simple, it is not that much, but this is the basic which is expected from us, that when you are working as a chief officer, you have a fair amount of idea what is this reliquefaction system and how it takes place. So in cascade, the cargo in condensing evaporates the liquid, that is your Freon 22. Vapors are then taken through a conventional closed refrigeration cycle, condensing against a seawater. Cascade cycle is used for fully refrigerated cargoes. So again, it depends how much we have to load. But here another thing is that the plant capacities are not so affected by seawater temperature changes as per the other reliquefaction cycles. अब आपके आ जाते हैं कार्गो ऑपरेशंस. So कार्गो ऑपरेशंस जिन्होंने गैस कैरियर्स नहीं किए उनके लिए भी yes, it is slightly different from the tankers. Of tankers में क्या है, when the tanker comes from a yard, what we do, inspect the tanks and we inert and then we do the loading. तो यहाँ पे थोड़े से steps जो हैं अलग हैं. Now again the tanker coming from the yard, first thing is tank inspection, then drying, then inerting, then gassing up, cooling down, and then loading. So it is not that immediately we come from the yard, inerted the tanks and we start loading. First of all, preparation for loading is the tank inspection. So before any cargo operations are carried out, it is essential cargo tanks are thoroughly inspected for cleanliness, all loose objects removed, and all fittings are properly secured. So this is normally done before we come out of the yard. So all this inspection, everything is done up. But now your tanks are absolutely at ambient temperature and normal atmosphere is there inside. Now in addition, any free water must be removed. So when we are seeing the cleanliness, no water. And once this inspection has been completed, the cargo tank should be securely closed and then drying operations may start. Now second step is the drying. Now, drying the cargo handling system in any refrigerated ship is necessary because we don't want any water, nothing, no vapors, hydrate formation नहीं होनी चाहिए. So this means the water vapor and free water all must be removed from the system. And if this is not done, the residual moisture can cause problems with icing, hydrate formation within the cargo system. And tank atmosphere drying can be accomplished in several ways. These are described like drying using inert gas from shore, drying using inert gas from the ship's plants, or onboard air drying systems, whatever is fitted. अब अपने drying के बाद next comes the inerting. Of course, same to remove oxygen from the tanks because we are going to load a cargo whose vapors, of course, can make a flammable mixture. So definitely it is necessary that we remove the oxygen from the tanks. So this is what we call inerting. And inerting cargo tanks, cargo machinery, pipeline is undertaken primarily to ensure no non-flammable condition exists during the subsequent gassing up with cargo. And to do this, oxygen concentration must be reduced from 21 to again 5-6% to be on the safer side. अब inerting तो हो गई. Now inerting से हमने क्या किया? We have introduced nitrogen, carbon dioxide. Tanks dry भी हो गए, oxygen भी remove हो गई. But next problem is this nitrogen and carbon dioxide. ये जो गैस है, this cannot be condensed by the ship's reliquefaction plant. अब जब हमने कूलिंग करनी है तो वेपर्स को कंडेंस करना है, so ये तो कंडेंस होगी नहीं. तो इसके लिए we have to remove this also from the tank. So how this is done? Again, this is because at cargo temperatures each is above its critical temperature and therefore incondensable, both carbon dioxide and nitrogen. So accordingly, removal of this inert gas from the cargo tank is necessary. So this is achieved by what we call gassing up. So using the vapor from the cargo to be loaded at ambient temperature and venting the incondensable to atmosphere so that subsequently the reliquefaction plant can operate efficiently. So we introduce the cargo, which definitely at a slow speed, when it enters it will immediately get vaporized because your tanks are warm enough, and these vapors will start collecting in the tank, and finally this vapor pressure will remove your IG, which is vented out. So slowly a stage will come that when you find there all your IG is removed and you have only cargo vapor. So this is also what we call it a gassing up stage. अब gassing up के साथ साथ आपकी cooling भी हो जाएगी. Now cooling down is necessary to avoid excessive tank pressure and also thermal stresses. Tank आपके normal temperature पे I'm going to load at -50, -60 or -100. So tanks need to be cooled. And ये जो cooling down है takes lot of time. So first time of course it takes. Every time we cannot afford. Because cooling down, as I told you, it has to be slowly. We cannot immediately cool within 2 hours from +20 say -100 पे cannot. Again it can damage the tanks. So cooling down consists of spraying cargo liquid into a tank at slow rate to lower the cargo carriage temperature. The more important is the cool down procedure, so which is sometimes written in your manuals also, that at what rate you are supposed to cool down your tanks. So before loading a refrigerated cargo, ship's tanks must be cooled down slowly in order to minimize the thermal stresses. So the rate at which a cargo tank can be cooled without creating high thermal stress depends on the design of the containment, and typically it is about 10 degrees per hour, 10 degrees centigrade per hour. Now if I have to cool down say from 20 degree to minus 100, so at least 12-14 hours ship will be idle, just cooling down the tanks alongside. So initially तो करना ही पड़ेगा. उसके बाद we have a different process. The ships are on the same cargo, same run, but initial cooling के लिए, now again the reference should be always made to the ship's operating manual, that what is the cooling down rate, at what rate we should cool down these tanks. So इसका process is simple. The cargo liquid from the shore is gradually introduced into the tanks either through a spray lines if fitted for this purpose or via cargo loading lines. And the vapors produced by rapid evaporation may be taken ashore or handled in the ship's reliquefaction plant. So जैसे जैसे vaporize होगा तो आपके टैंक को ठंडा भी करता जाएगा, because the vapors are cool. So excessive vapors जो हैं उनको हम वापस reliquefy करेंगे और they are taken ashore. So meantime these vapors will keep on cooling your tank, and we do not let the extra pressure also generate due to too much vaporization. So this circulation, this process is continued, and additional liquid is introduced at rate depending upon the tank pressure and temperature. So आपने इसको reliquefy कर दिया, वापस वही liquid आया, again evaporate होगा, and again converted back to the vapors and then back to the reliquefaction plant. फिर slowly थोड़ा सा liquid आप introduce करोगे. So slowly when your tanks are cooled down, one stage will come that when you introduce that liquefied gas, when आप cargo introduce करोगे, it is no more vaporizing. जैसे temperature ठंडा हो गया, the tanks come to that temperature, so you will find that liquid starts remaining as liquid, and you start getting that indicator on your gauges that now the cargo is retaining in the tank. So cool down should continue until the boil off eases and liquid begins to form in the bottom of the cargo tanks. And this can be seen from the temperature sensors throughout the cool down. Deep well pump shaft should be turned frequently by hand to prevent pumps from seizing up or freezing up. And once the cargo tanks have been cooled down, cargo pipeline equipment, then accordingly it is cooled, and then we start the loading. अब loading के लिए again preliminary procedures before loading begins. Pre-operational shipshore procedures, यहाँ पे भी shipshore safety checklist है, thoroughly discussed between the ship and the terminal carried out. ये तो extensive है, सारे checks आपके carry out किए जाते हैं before the loading starts. So particular attention is paid for the setting up of the tank relief valves and high alarm pressures. Remotely operated valves, reliquefaction equipment is working good, gas detection systems are working good, alarms and controls, and the maximum loading rate. The terminal should provide the necessary information on cargo, including inhibitor certificates where inhibited cargoes are loaded, and any other special precautions for specific cargo should be made known to the ship. So दोनों तरफ से है, the ship and the terminal both. This information exchange through the checklist is made, and even the ballast system for gas carriers, of course, it is totally independent. So we can simultaneously do deballasting, that when you are loading, ship stability stresses again maintain as planned. Of guidelines for completing the shipshore safety checklist, also similar to what we do on the tankers. तो इसकी guideline भी आपको यहीं पे है कि what all information should be available. Information available for safe cargo handling, including innovation certificates, information on each product, MSDS, what we call, and it should be in written format, and also include storage plan, description of physical chemical properties, action to take in the event of spills. So this becomes important that we have gone through, we know in case some mishap takes place, then how I'm going to handle. Countermeasures against accidental personal contact, firefighting procedures, and what media I'm going to use. Procedures for cargo transfer, gas freeing, ballasting, tank cleaning, and changing cargoes, and special equipment needed for safe handling of the particular cargo. minimum allowable inner hull steel temperatures and emergency procedures. Of course, when inhibited, certificate हमारे पास होना चाहिए, उसका name, amount, shelf life, will it stand, the duration of the voyage, and action to be taken should the length of voyage exceed the effective lifetime of the inhibitor. तो ये सारी की सारी information हमारे पास पहले से होगी. And is the water spray system ready for use? And in case where flammable toxic products are handled, water spray system should be regularly checked. And during operation, system should be kept ready for immediate use. These are standard procedures हैं, which these gas carriers normally people working they are familiar, they do. And again, protective equipment, SCBA, suitable protective equipment, self-contained breathing apparatus, eye protection, protective clothing. यहाँ पे तो that's why these ships they work in a more safer way, because we keep all these things, equipment, everything ready every time. Storage places for this equipment should be protected from weather, clearly marked, and personnel directly involved in operation should utilize this equipment and clothing wherever the situation. सबसे पहली चीज़ तो of course हमारा equipment, हमारी clothing, हमारी PPE what we call. So before we handle these cargoes and personnel required to use breathing apparatus, they should be trained. हर चीज़ के लिए of course the ships people who work they are regularly going on this, so they are well aware of this. All holds interbarrier spaces also inerted. ये भी check जरूरी है. Spaces that are required to be inerted should be checked by the ship's personnel. Remote control valves and ship and shore cargo system remote control valves and their position indicating system should be checked. And of course alarms and sensor, definitely we keep regularly checking up. Cargo pumps, compressors, good order, have minimum or maximum working pressures to be agreed. And agreement in writing should be reached on maximum allowable working pressures in cargo line system during operation, like what we have the loading rates, that they are decided before at this rate, and continuous watch is kept. Reliquefaction or boil off control equipment is working even while loading. Sometimes you need excessive vapor generation takes place because temperature will fluctuate. If you are loading cargo at -100, so by the time we load, so slight temperature going up, the cargo will boil off. And if this boil off is not taken care, you will find excessive pressure generating in the tank. So it should be verified reliquefaction and the boil off control systems are functioning correctly prior to commencement of the operations. Gas detection equipment properly set. Span gas should be available. Calibration of the equipment and fixed gas detection system should be calibrated for the product to be handled. Portable gas detection instruments, no need for me to mention. We all know portable instruments capable of measuring inflammable range should be calibrated for the product. And cargo system gauges, alarms correctly set and in good order. Ship shore cargo system gauges regularly checked. And again the alarms, different level alarms, and alarm should be set to the required level. Emergency shutdown. In case, of course, we have the high level alarms, level comes, and that's what the, if something is emergency on the, it is shut down on emergency basis, then what action to take. And ship and shore emergency shutdown system should be tested before cargo transfers take place. And shore also, of course, they exchange information, they know the closing rate of the ship's automatic valves and automatic shutdown valves may be fitted on the ship and shore दोनों side में. The action of these valves can be automatically initiated by a certain level is reached. So उससे पहले ही, of course, we stop cargo, we don't come this automatic system to shut down. Again, loading rate, it depends. And safe cargo handling rate should be noted in this agreement. Information being exchanged about maximum temperature pressures, and before operations comment, information should be exchanged between ship and shore on cargo temperature pressure requirements. Cargo tanks protected against overfilling. Of course, we have the alarms, automatic shutdown system that also works. Compressor room properly ventilated, motor room pressurized, and alarm system working. Fan should be run at least 10 minutes before cargo operations commence and then continuously during cargo operations. So compressor rooms are important. Pre-liquefaction plant is operating. Audible alarms. Cargo tank relief valve sets and उनका maximum relief valve setting वो भी थोड़ी सी increase कर दी जाती है initially. In cases where cargo tanks are permitted to have more than one relief valve setting, should be verified, and it is set as required by the cargo to be handled. And relief valve setting should be recorded in the checklist. Trim stability stress, of course, we check before loading. आपकी cargo planning हो गई है. Sloshing, further point to be noted in respect of tank filling level that large prismatic cargo tanks, due to their width and shape, may suffer from substantial sloshing of cargo in heavy pitching or rolling conditions. So normally we keep these tanks full up to certain level so that during sloshing or during rolling pitching there is no damage takes place. अगर हम tank को full रखते हैं so less damage. Tanks half empty होगा, more damage because liquid will go from one place to another place, can damage any structure. So such tanks, and particularly membrane type of tanks which have no centerline wash bulkheads, may have prohibited filling levels in order to avoid damage to the tank structure. So typical controls on such tanks are prohibition on all filling levels into 10 to 80%. अब आपका एक आ गया कार्गो हील, ये भी कभी पूछ लेते हैं ना. कार्गो हील क्या चीज़ है कि जैसे हमने देखा है वी आर स्पेंडिंग लॉट ऑफ टाइम इन cooling the tanks. So एक बार तो हो गया. Every time if the ship has to spend just 12, 14, 16 hours for cooling, so then it is not a viable project. So उस चीज़ को that your tanks remain cool, so subject to trading patterns of the vessel, a particular requirement of the charter, cargo heel may be required. Cargo heel is a quantity is allowed for in the discharge plan, and pumps are to be stopped at required LHs. That means certain amount of cargo is retained in the tanks so that your tanks remain cool. So each ship will have its own specific instructions within operating manual detailing the required quantities and procedures to be followed. Now this heel figure should be carefully calculated to ensure there is maximum outturn of cargo at discharge port, consistent with being able to arrive at a load port with tanks cooled down by the onboard retained heel. So this part of the cargo, it is again between the charterer. Now it's the same charterer, they know. So they keep certain part of the cargo that which keeps the tanks absolutely cool. So retention of heel is subject to much discussion. On membrane vessels or shorter ballast voyages, it is acceptable to carry a small amount of heel in each of the cargo tanks, and generally this will maintain the tank bottom temperature sufficiently cool. So आपको अपने tanks, when you come to the load port, you don't have to spend so much of time. So this is what we call the cargo heel, and its amount varies charter to charter, and vessel is able to berth and commence loading without additional tank cool down being necessary. Longer voyages, usual for heel to be retained in one tank with others heeled out, and additional spraying may be necessary when cargo tank temperature is higher than your arrival temperature requirements. Terminal requirements also followed, intention being for the vessel to arrive without the requirement for extended cool down and delays at load port. And on long ballast voyages with large quantities of heel retained in one tank, essential the quantity of heel carried does not exceed normally about 10% of the tank height. Okay, again sloshing का भी है कि हमने देख लिया. So we have to keep that much that it does not do any damage to the tank, and amount is also sufficient to keep my tanks in a cool down condition. चलो ये तो था आपका various procedures, various things what we do on these gas carriers. So please go through this. क्वेश्चंस आपको बता दिए कि यस हैजर्ड्स ऑफ गैस कैरियर्स, रीलिक्विफिकेशन प्लांट, इसके ऊपर भी क्वेश्चंस रहते हैं, एंड टाइप्स ऑफ गैस कैरियर्स, what are the various types of gas carriers, containment system. I think this is, if you can go through, not so difficult, and people who are working, so they also have a tendency to attempt this gas carrier. या एक क्वेश्चन रहता है जिसमें केमिकल कैरियर और गैस कैरियर का भी हो सकता है, अदरवाइज यू हैव अ चॉइस या नहीं करना। जिन्होंने टैंक दिस टाइप ऑफ शिप्स नहीं किए उनके पास भी चॉइस है कि चलो यार वाई स्पेंड एक्स्ट्रा टाइम, नो। बाकी जो टैंक्स की जो टाइप के शिप्स किए हैं जिनके बारे में आपको नॉलेज है तो आप उन क्वेश्चंस को भी अटेम्प्ट कर सकते हो। अदरवाइज थ्योरी में आई थिंक इससे ज़्यादा यू डोंट नीड टू नो वेयर एज योर आंसरिंग द क्वेश्चन इज रिक्वायर्ड। ठीक है, चलो, एनी क्वेश्चन फ्रॉम एनीबडी? हो जाएगा गैस कैरियर्स? क्या कहते हैं, बोर हो गए लगते हैं?
हो जाएगा।
एनीवे, चलो बच्चे, रिटर्न्स में तो चॉइस है, बट आइडिया इज कि अगर इफ यू कैन गो थ्रू दीज मैनी नोट्स, ओरल्स में तो कई बार पूछ सकते हैं, तो ओरल्स में तो हम नहीं मना कर सकते। सो आप इफ यू हैव नॉट डन, स्टिल you are not absolutely blank, so you can definitely say which are common, the hazards are common with your chemical tankers, and slight operational procedures are different. So after going through reading once or twice, so you can definitely well understand कि यार गैस कैरियर है क्या, इसका डिज़ाइन क्या, IGC कोड्स क्या हैं, एंड क्या क्या प्रिकॉशंस मैंने लेनी है। एंड lastly you can say कि yes, the examiner knows you have not worked on this, but if he sees you have put some attempt to learn little bit, so he is happy. चलो ठीक है, आज के लिए इतना ही। तो
सर एक बात पूछनी थी सर।
हाँ जी, बच्चे बोलो।
सर जैसे ये टाइड के क्वेश्चन में एक क्वेश्चन आया हुआ है, किसी पोर्ट का पूछा उसने कि ये क्लियरेंस वगैरह एक उससे शैलो वाटर से निकलना है विद सम क्लियरेंस, और वो पोर्ट का डाटा सर पीछे ना नॉर्मल उसमें दिया है ना हार्मोनिक कांस्टेंट में दिया है, बट हम उसको अगर देख रहे हैं तो वो सेकेंडरी पोर्ट आ रहा है।
Do you know the name of the port?
यस सर, रैंगून रिवर एलिफेंट पॉइंट।
Rangoon River Elephant Point.
करेक्ट सर। अगर हम वॉल्यूम 2 का वो स्टैंडर्ड पोर्ट्स का देखें तो उसमें दिखा रहा है ये स्टैंडर्ड पोर्ट है,
ओके,
बट अगर पीछे डाटा में जाएं तो ना सर हार्मोनिक कांस्टेंट में इसका डाटा मिल रहा है ना नॉर्मल पोर्ट्स में, तो ये तो फिर हम सिंपल इसको स्टैंडर्ड पोर्ट समझ के कर देना सर।
या अगर तो ये स्टैंडर्ड पोर्ट है ना, इफ इट इज अ स्टैंडर्ड पोर्ट,
यस सर।
एंड इफ दे वांट सी टाइडल प्रेडिक्शंस आपको दी हुई हैं,
करेक्ट सर, उसको तो डायरेक्ट कर सकते हैं ना सर फिर इसको।
करेक्ट, बट अगर आप कह रहे हो मेरे को देना, मैं चेक कर लूंगा।
देख लो सर, ये रैंगून रिवर एलिफेंट रिवर पॉइंट सर, वॉल्यूम 2।
या मैं चेक कर लूंगा, आई विल गो थ्रू दिस टाइप टेबल्स एंड नेक्स्ट वीक आई विल लेट यू नो। क्वेश्चन क्या है, अगर आपके पास क्वेश्चन है तो चाहे व्हाट्सएप पे डाल देना ग्रुप में।
ठीक है सर, मैं क्वेश्चन डाल देता हूँ, है क्वेश्चन मेरे पास।
क्वेश्चन है तो डाल देना। वैसे मैं पोर्ट देख लूंगा। आई अंडरस्टूड योर पॉइंट कि अगर दोनों में डेटा ही नहीं है, सेकेंडरी पोर्ट में भी और इसका SHM में डेटा ही नहीं है।
यस सर।
बट बच्चे कई बार होता है कि हमारे जो ये बुक है, जो हमारी टाइप टेबल्स हैं, ये कंसोलिडेटेड पेजेस हैं, और ये फोटोकॉपी चलती है तो इसमें कहीं ना कहीं कई बार पेज भी मिसिंग हो सकते हैं।
हाँ, तो फिर तो हम सर इसी के हिसाब से ही निकालेंगे ना जो हमारे पास इंफॉर्मेशन अवेलेबल है।
करेक्ट, अगर आपको एग्जाम में इफ ही गिव्स यू द टाइप टेबल एंड उस टाइप टेबल में ये पोर्ट ही नहीं है, डेफिनेटली आई कैन नॉट डू।
करेक्ट सर।
इजंट इट? पर मैं देख लेता हूँ कि ऐसा ना हो, बिकॉज आई हैव गॉन थ्रू सर्टन क्वेश्चंस की किसी इवन जब हम कॉलेज में थे तो वहाँ पे मैंने देखी है कि बुक्स में पेज मिसिंग होते थे, वो डेटा ही नहीं है।
एक बार देख लीजिए, क्या पता सर मेरे से कुछ गलती ना हो रही हो, मे बी।
ठीक है, मैं कर लूँगा बच्चे, चेक कर लूँगा।
ठीक है, मैं सर व्हाट्सएप पे डाल देता हूँ अभी।
क्या रंगून ना, रंगून एलिफेंट पॉइंट? वॉल्यूम
यस सर, रंगून रिवर एलिफेंट पॉइंट।
कर लूंगा बच्चा, मैं चेक कर लूंगा, आज ही कर
Okay.
लूंगा। आई लेट यू।
थैंक यू।
चलो, एनीथिंग एल्स? चलो, ऑल राइट, कॉल इट अ डे फॉर टुडे।
Yes, sir.
चलो, ओके डियर, देन बाय बाय।